This video covers topic 1, functions and inverses. We're going to start off with the first portion of this, which is functions, where we're going to determine whether a relation is a function by looking at tables and mapping diagrams, sets of ordered pairs, or graphs. Really, we want to know what is this relationship between a relation and a function. So before we jump into what a function is, let's think back to Algebra 1 when we learned about relations. A relation is a set of ordered pairs, and they are most commonly viewed as either ordered pairs, tables, graphs, or mapping diagrams. And if you remember, we had specific names for the x's and the y values. We called the domain the set of input values, or these were our x values, and the range was our set of output values, or these were our y values. So looking at our ordered pairs, we remember that our x values are first and our y values are second, meaning that our domain is going to be -2, 0, and 3. We're not going to repeat the repeated value. And our range then is going to be -2, 1, and 2. Again, not repeating the repeated value of 1. From a table, they already give it to us. The x's are our domains and the y's are our range. In a graph, if we remember from Algebra 1, the x-axis goes side to side, so that is our domain values come from there, and our y values come from the y-axis, which goes up and down, so our range is vertical as well. From a mapping diagram, it kind of looks like the table, that our domain values are the first bubble on the left, and they map into our range values on the right. So if that's what a relation is, let's go back to the other side of our notes, or the pride side with our lion head on it. What is a function then? Well, a function is a relation, except that we have a unique relationship between the x's and the y's, in that every x value corresponds to exactly one y value. Another way of saying this is that every value in the domain goes to exactly one value in the range. There are no repeat x values going to different y values in the range. Another way to think about this, or really just the idea of a function, is that it's predictable. And what I mean by predictable is if I tell you an input value, you should 100% know what y value is going to come out of it. There shouldn't be any guessing whether it's going to be A or B. It should always go to exactly one output value. Think about it like a cheers that you hear at a basketball game. The cheerleaders say, I say red, you say black. And then when they say red, if the whole crowd doesn't yell black, the one output value, clearly something's wrong. If half the crowd is yelling aqua, then we have an issue, right? It should be predictable in terms of every x value goes to exactly one predictable y value. Every value in the domain goes to a predictable known value in the range. So let's take a look at what that looks like. Zooming in a little bit. We have some examples of a function and not a function in all of our different methods. So as you can see here, we'll start off with a variation of a mapping diagram using some real-world data. An example of a function here is a person's name mapping to their birthday. This is in fact a function. If I ask you what's Colleen's birthday, there is only one predictable answer, and that would be January 8th. Every person is going to one birthday. Every x value goes to exactly one y value. It's okay that there's a repeat. People can have multiple people can have the same birthday, but multiple people or a person cannot have multiple birthdays. So our reason behind this is every person, which is our x values, has only one birthday, which was our y values. An example of not a function using that same idea is hours worked compared to salary. So if we're all working the same job, right? And if we're just working differing degrees of hours, if you and I both worked 20 hours at the same job, it doesn't make any sense that I would get paid $200 and you would get paid $300. If we're doing the same job, it doesn't make any sense that this one input should go to two output values. So the reason it's not a function is we see that one input, or hours worked, has multiple outputs, and that would be $200 and $300. A function is predictable. We should be able to predictably say this input goes to exactly this output. All right, well, let's take a look at what it looks like in a set of ordered pairs. We see the set of ordered pairs here. Looking very quickly at our x values compared to our y values, we see that there are 4 unique x values, and they are all going to their own y values. So this is an example of a function. Or in this case, every x value goes to exactly one y value. On the other case, if we look over here at not a function, we see right here 20 maps a value of 20 in the x goes to 1 in the y's, but also down here, x value of 20 also goes to 10 in the y's. This is not predictable. If I tell you the number 20, you should be able to tell me the exact y value that it's coming to, or in this case, the x value goes to multiple y values. 20 goes to the y value of 1 and also 10. Not a function. Looking at a table of values, it's very similar to XY coordinates, except we group them in a nice organized table. Looking at my first table here, we see that there are 4 unique x values and they're all going to a y value. There are no repeat x's. So we see the exact same reason as before. Every x value goes to exactly one y value as in the previous. Looking at our table that's not a function, we can see that right here, x value of 10 goes to 1, and x value of 10 also maps to 3. So we are again going to have a very similar reasoning as before. X value goes to multiple y values in our table. Not a function. The last 2 examples are a mapping diagram and a graph. Looking at the mapping diagram, we can see that we have our domain and range, left and right. And in our function example, we see that the x values of 1, 4, and 13 all go to one unique y value. So once again, we have the same reasoning. Every x value goes to exactly one y value. Looking at the mapping diagram that is not a function, here we see that the x value of 4 goes to 2 y values. The value of 4 outputs to 14 and outputs to 0. So once again, we have an issue. We see our x value of 4 goes to multiple y values, in this case 14 and 0. Okay? It shows up as repeated x's in ordered pairs, repeated x values in a table, but here we see that we have 2 arrows. As you can see, 2 arrows coming out of the same number in our mapping diagram. Another visual cue as to what's going on. One x value goes to multiple y's. Okay, let's take a look at the graph. This first graph that we have here is a function, and these are just xy ordered pairs. We could go through and name all these points. This is the point 1, 5. This would be the point 2, 1, and so on and so forth. Looking at this very visually, though, we have something, if you recall, from Algebra 1, looking at the left-hand side, we know about something called the vertical line test. Yes, you did this in Algebra 1. It's a quick, easy way to determine whether or not a function relation is a function via their graph. And what it says is that a relation is a function if and only if the graph does not intersect a vertical line at more than one point. So I have 2 examples for us. These first 2 examples are of graphs that pass the vertical line test, meaning that if I took and I drew a vertical line anywhere through this graph, it would only intersect the vertical line at one point. So therefore, it must be a function. It passes the vertical line test. Same thing here on this graph. I can put it in multiple spots. Just a quick zoom in on this graph. If I drop a vertical line at x equals -2, it may look like it hits, but what's happening there? There is a hole in the graph. So my line is essentially going to go, I'm going to do that in green here coming down. It's going to go straight through the hole in the graph, so it really only still intersects it at one point. So this is an example of a graph that passes the vertical line test. So since it passes the vertical line test, we know that every x value here on the x-axis goes up to only one y value. So another way to think about that is coming from the x-axis. If I pick any value on the x-axis, so here if I pick -2, I only go up and hit at one spot on the y value. Things that fail the vertical line test, here's some examples of that fail the vertical line test. If I draw a vertical line through these 2, what that means is at the x value of, let's say, 4, I don't just have one y value, I actually have 2 y values that it maps to, and that's not healthy. Here, if I'm at -2x, I go up and I see that it intersects at 2 y values, which is not healthy and not appropriate for a function. So vertical line test is kind of a quick and easy way for us to go ahead and check whether or not we have a function. So back to those 2 examples that I have here. If I look at just these individual points, I draw a vertical line through each of these points, it's only going to hit one point individually, versus here on my graph, if I draw a vertical line at x equals 3, notice that we have this vertical line intersecting at 2 points very similar to our other graphs. So this, in fact, fails the vertical line test. It works for connected graphs or just discrete individual points. So our reasonings then are basically going to be the same as it was before, except we can shortcut our reasoning y, just simply saying that it passes the vertical line test and fails the vertical line test implies that if it passes, every x goes to 1y, or if it fails, an x value has more than one y value mapped to it. So kind of a shorter reasoning for us looking at that. Let's take a minute and try practice A on the left side of your paper. Go ahead and identify the domain and range for me for each of these examples, and then tell me whether or not it's a function and give me an explanation. I'll give you a few moments to do that. The answer will appear in 3, 2, 1. Answer is projected. Go ahead and check your answers. If you have any issues, go back and see if you can fix it. Ask a table mate, and if your whole table is stuck, go ask me. Moving on.